Hello student, I'm Sonali Kelkar from City International School. Today we are going to start with a topic reflection and refraction in light, right? And we have discussed this topic before, but I want to today discuss about the concepts of the topics, as well as we will do few numericals so that the concept will get more clear. Okay, so let's start with the refraction of light. Okay, so what can you say in this picture? Here we can see that the light which is coming right straight from the air, it got bent over here, right? Because of that, you can see the position of real fish is here, but it has shifted to some other place just because there is a refraction of light. So apparent position of fish is here. So that is why it's very difficult to pick a coin. If it is dipped in a bucket full with water, it is very difficult to pick a coin at one instance, right? Because the apparent position has changed, right? And here also we can see pencil, it is looking much shorter. When you dip a pencil, it looks much shorter and it looks bulging out from the surface, right? So why these phenomena? What is the reason of these phenomena? We have done that. It is a refraction of light. Now what is the refraction of light? When light travels from one medium to another medium, okay, at the boundary of the two medium, it bends. So this bending of light is known as refraction of light, right? But why this happens, right? What is the reason of bending the light? The reason for the bending of light is there is a change in the speed, right? And why there is a change in the speed? If I ask you why there is a change in the speed, there is a change in the speed because the two medium, let's say air and water in this case, okay, the two medium have a different optical density, right? Now what this optical density is, right? It is just like suppose you are moving on a highway, right, where there's hardly any traffic. Okay, you are moving on a highway, there's hardly any traffic, so your car will go straight in the same direction. It will go straight in the same direction. Okay, but all of a sudden, when some bus or let's say some truck comes in front of your car, then what happened? Then you need to take one shortcut, right? This is nothing but a refraction of light. This is what happened in a optically denser medium. That means the particles in an optically denser medium are so compact and closely arranged that light has to take some other path to move, right? So there is a bending of light, okay, which you can observe. So this is what is optical density of two medium. The very important thing over here, the optical density, please don't get confused with the optical density with the density regarding the normal density with respect to mass. Okay, so two densities are different, right? How can I, let's take an example. How can I say that two density are different? Have you ever seen uh, okay, there's a beaker filled with water. If I put kerosene on this beaker, what will happen? What will happen? Well, will kerosene will go and settle down, or will kerosene will float on the water? Okay, the kerosene will float on the water. Why this is floating on the water? Because the density of kerosene is lesser than the density of water. So this is a density which is with respect to the distance between the particle. Less the distance between the particle, the density is more the distance between the particle, the density is less, right? So this is what. But what is optical density here? The optical density is not like this. Okay, optical density is different from the density of the substances. Okay, now optical density in case of kerosene is denser. It is much denser than water. So in this case, optical density of kerosene is more than optical density of water. Okay, we are talking about optical density. Here it's not coming very well. Fine. So here we can see that is why what happened when a light travels, from denser medium to the rarer medium. What happened? The light travels from the denser medium to the rarer medium, right? So we know that we have done in last that when light travels from the denser medium to the rarer medium, it bends away from the normal. So let's see in different example. Okay, here I have taken the medium. This medium is a glass block, or we can say glass slab. Light is coming from air to the glass slab at the point of the two medium where they are meeting, the boundary of the two medium, right? This light, ray of light will get bent because light is traveling from rarer to the denser medium. Rarer medium, whenever I say rarer medium, it is a optically rarer medium, and this is optically denser medium, right? So when light moves from rarer to the denser medium, light bends towards the normal. This is a normal. So whenever you draw such type of diagram, so draw first the two medium, right? You can draw a line and then immediately draw a normal. Then you draw a line of incidence, right? Incidence ray, okay? And this if you can see, it is bending towards the normal, right? So it bends towards the normal, and this is the glass block. Here again light is going back into the air, so this is a boundary between the glass and the air. Over here again the light will bend, but this time this light is bending away from the normal. Okay children, so this particular is called emergent ray. Okay, now this is incident ray and this is refracted ray. Now what is incident ray? It is the angle between normal and incident. If problem comes, most of the times children get confused. It is not the angle which is, let me tell you, it is not this angle, or neither it is this angle, right? It is this incident angle between the normal and the line of incidence. And what is refracted ray? It is angle between the refracted ray and normal. So whichever angle is made with normal, okay, with incidence ray is an angle of incidence, and with refracted ray it is angle of refraction. Clear? So this is how the light travels. So light travels, the angle of refraction, fine, is depend upon the deviation of the light from its main path. The light has deviated from its main path. It depends upon the optical density of medium. This is very important point, right? Then the velocity of the light in medium is more than medium the medium is called optical rarer. Okay, when the velocity of light is more in this medium, if this is air and the velocity of light is more in air, okay, then we call air is a rarer medium. This is a rarer medium. It means optically rarer medium. Fine. Now coming here to the second diagram, here you can see the angle of incidence. Okay, it is perpendicular the surface. Angle of incidence is perpendicular to the surface. So in this case, angle of incidence and angle of refraction, that means the angle between the normal and the incidence is nothing. It is 0, right? So angle of incidence is 0. Now even the angle of refraction is also 0. Okay, so whenever the rays are coming whenever the rays are forming a 90-degree angle with the surface, or whenever the rays are perpendicular to the surface, that time angle of incidence and angle of refraction are 0. Okay, this can only happen, when can this happen? This can only happens when the two medium has the same refractive index, right? Now we are going to tell you about refractive index. No refraction, fine. Here there is no refraction because the rays, incident ray is perpendicular to the surface. Okay, the surface, it is a boundary between the air and the glass. Over here, incidence ray is just perpendicular to the surface, so there is no refraction. Okay, refraction will also won't take place when the two medium have the same refractive index. When the refractive index, when the RI, refractive index, I'll write the short form of refractive index, when the refractive index of two mediums are same, right? Medium 1, let's take medium 1 and is equals to refractive index of medium 2. They are same, then there won't be any refraction of light, right? So here you can say one more thing here you have to observe. When can I say that angle of incidence, okay, is greater than the angle of refraction? When can I say? In which case? When the light is moving from rarer to denser medium, or when it is moving from denser to the rarer medium? When we can say, this is a very important question which can be asked in exam. So if you see here, the angle of incidence is 45, right? Angle of refraction is 28. So in this case, the light is moving from rarer to denser medium. So in this case, when light move from the rarer to the denser medium, angle of incidence is more than angle of refraction. Now let's see the other case. So here we can see that this is angle of refraction 28, because it is made between the refracted ray and the normal, right? This is the normal. So 28 and angle of incidence is 45, right? So here the angle of incidence is smaller. Angle of incidence is smaller than the angle of refraction. Okay, this is possible only when the light moves from, this is what, denser medium, this is a glass. So the light moves from the denser medium, optically denser medium, to optically rarer medium, right? Here, what type of phenomena you can observe in this picture? You can see the pencil, right? It is supposed to be like this, right? But you have seen there is a little displacement in pencil, right? So what is this displacement is called, and how does this happen? So let's have a look. Here we call such type of displacement a lateral displacement. What do you mean by lateral displacement? If you see, it is a perpendicular distance, right? This is an incidence ray coming from here, and if we draw a line where the incident ray is not getting deviated, okay, it is not getting deviated, I just made a straight line, okay, but in actually it get deviate because there is a change in the optical density of the two medium. So because of that there will be a change in the speed. So due to the change in the speed, this light has deviated from its original path, right? So this distance, what is a lateral distance? It is a distance, okay, which is, it is a perpendicular distance between the original path. This is the original path, right? Original path, OP, original path, perpendicular distance between the original path and the path traced by the emergent ray. Okay, this is the original path and the path traced by the emergent ray. So perpendicular distance between the original path and the path traced by the emergent ray is nothing but lateral displacement. And just because of this lateral displacement, you saw that pencil was looking literal pencil was looking like little bit on the side way. Okay, and this lateral displacement, it depends, the factor on which lateral displacement depends on, this depends on the thickness. This is the thickness. If I okay, if I take a slab, so this is the thickness of the slab, right? It depends upon the thickness of the slab. It depends upon the refractive index of glass slab. Okay, it depends upon Ri, refractive index of the slab, and the angle at which the incident ray enters the glass slab. This is also important, right? How can we relate that angle at which the incident ray enters the glass slab? Okay, let's take an example. If I increase, okay, angle of incidence, now what happened to the displacement, lateral displacement? Can anyone tell me? If I increase the angle of incidence, what will happen to the lateral displacement? This will also increase. Okay, so lateral displacement, my lateral displacement, okay, this will also increase. So this is how the angle of incidence is affecting the lateral displacement. Okay, if the angle of incidence more, lateral displacement is more. Okay, so this is all about lateral displacement. Okay, now let's do the laws of reflection. The first law of reflection, the both laws of reflection are given by Snell. Okay, the first law of reflection is similar to your law of reflection. So in this case also, the incident ray, the refracted ray, and the normal at the point of incidence all lie in the same plane, right? So this is very similar to the law of reflection, where you have to just replace the refracted ray with the reflected ray, right? What about the second point? Okay, the second says that a ratio of the sine of angle of incidence, this is sine I, this is sine of angle of incidence, the ratio of sine of angle of incidence to the sine of angle of refraction, okay, is constant. This constant is n. And what is the other name of this constant? Yes, it is refractive index. Refractive index. Okay, for index I'm just going to put I here. Refractive index. Clear? So we have three definitions of refractive index. I think 3-4 definitions of refractive index. We will come to know about all these definition of refractive index. So with this formula, can you make out the definition of refractive index? Yeah, okay, it is a ratio of sine of angle of incidence to the sine of angle of refraction is refractive index. Okay, which is nothing but constant. This constant is nothing but refractive index. Yes, now coming to refractive index, what do we mean by refractive index? It is the amount or the extent of bending of light when it passes from one medium to another medium, right? And this extent of bending, it depends upon the speed of light, isn't it? And speed of light depends upon, this depends upon the speed of light, and this depends upon optical, okay, density of light, optical density of the medium. Okay, now let's take an example. Okay, if I tell you the if I tell you the refractive index of glass is 1.52 and refractive index of water is 1.33, what can you infer from this information? What can you conclude from this information? Right? In which medium? Okay, in which medium the light travel fast? Okay, yeah, it's water, right? In water, light travel faster. Light travel faster in water because its refractive index is 1.33. So lower the refractive index, Okay, more will be uh, more will lower the refractive index, more will be the speed of light. Okay, and over here refractive index of glass is higher because the optical density is more. So if the optical density is more, speed will be less. Okay, so this is what is refractive index. Since the refractive index of glass is higher than water, the speed of light in water is faster than the speed of light through glass, right? So this is how we can make out. If I give you the refractive index of 2, 3 material, and if I ask in which medium the speed of light is fast, okay, the speed of light is more. So you can make out the material in which has a low refractive index, and that the speed of light will be more. Okay, if the refractive index of the medium is greater than that of another, the first medium is said to be optical denser. Okay, there are two type of refractive index. Now coming to the refractive index, this is very important because it is very important from the point of view of numericals. Okay, maximum numericals comes from refractive index, so this concept is very important. Now there are two types of refractive index. One is relative refractive index. Now relative word, the word relative means we have to relate two things, okay, because we have to set a relationship or we need to compare the two things. So there should be a relative, there should be a two medium in relative refractive index, right? So other than air, we are not taking air, other than air, let's take, okay, when light is going from one medium to another medium, then the value of refractive index is called relative refractive index, other than air. Now why did I say other than air here? Because when I say, if I include air, that means it will be a absolute refractive index, right? So refractive index of a medium or a substance with respect to air, okay, any substance with respect to air is considered as absolute refractive index. So that is why I haven't taken relative refractive index. Okay, I haven't taken air in relative refractive index. So let's take for an example in relative refractive index. We all know that refractive index is denoted by n or it is denoted by mu, but in your NCERT it is denoted by n. So we are going to take n, we are not going to take mu, right? So we have to follow NCERT, that is why I am taking n. But if in case you have taken mu, that is not wrong, that is absolutely correct. So if I take two medium, let me take two medium here. I can take refractive index of water, right, and refractive index of glass. I am taking for glass I am taking small g, for water I am taking W, right? So these are the two medium other than air. There can be, and the set of two medium, we have to take a single set of two medium. We can also take refractive index of water and refractive index of kerosene, as I have told you, right? Kerosene is optically denser than water, okay, remember, which is very important point. Or we can take diamond and water, that also we can take. So they are the different type of index other than air. For that we have to find out relative refractive index, and for that we have set of formulas, right? And absolute refractive index, there is only one formula, that is very easy. So let's have a look on the different formulas, right? So refractive index, right, divided into two parts, relative refractive index and absolute refractive index. So just one formula for absolute refractive index. The refractive index denoted by n is equals to c upon v. Now remember children, this c, small c, is always denoting the velocity of light in air. And one more thing, velocity of light in air or in vacuum is one and the same thing, right? Because there is no change in the velocity of air and vacuum. There is a change, very little change, but we don't consider that change. So we always consider that the velocity of light in air and vacuum is same. Okay, so you don't get confused. Now V is what? Velocity of light in medium. This medium can be any medium. This medium can be water, this medium can be glass, this medium can be kerosene, this medium can be diamond, right? So if this is the formula of absolute refractive index, right? So light is passing from air. In this case, light is passing from air to, let's take water. Okay, let's take water. Air to water. Fine. This is very important, children. These concepts you have to know. This is my medium 1 because light is passing through the medium A. Light is passing from A to medium 2, water. Okay, from air to water light is passing. So this is my medium 1 and this is my medium 2. Clear? So you have to be clear that which medium is 1, which medium is 2. So whenever the first medium is air, whenever the first medium is air, if I say the light is passing from air and it enter to water, right, and find out the refractive index of water, in that case you can also write N is equals to W, that is refractive index of water directly. You don't have to write air and water first, right? You can directly write refractive index of water is equals to, okay, speed of light in vacuum divided by the speed of light in the medium. Now what is the speed of light in water? That will be given in the numericals, right? So speed of light in water, this should be the speed of light V. I will write VW, speed of light in water. Okay, is this clear? Now coming to, this is what is a absolute refractive index, and here I can also form one more definition of a refractive index. So here I can say that refractive index, N is a refractive index, right? So refractive index is a ratio of velocity of light in air to the velocity of light in medium. Clear, student? So here we got the second, okay, a definition of refractive index. Now coming to the relative refractive index. This is a very important point and you should pay a lot of attention. You should understand the concept because most of the numerical will be based on this, right? So this we have already done. Refractive index N is equals to, it is equals to sine of angle of incidence to the sine of angle of refraction, right? So sine of angle of incidence, that is the angle which will be given in the numerical. Refraction also will be given in the numerical and their value will be given in the numericals and you have to solve them. So very simple numerical will based on this. So this was the very first Snell's law definition of refractive index. Then this is the second definition of refractive index. Now coming to the next point. Then I told you that it is a relative refractive index. That means I have to consider the two medium. Okay. So there should be a one set of two medium, right? So what should be that? Medium 1 and medium 2, right? So how will I write refractive index of medium 1 and medium 2, okay, with the ratio of sine I and sine R? So let's see here. Now how I'm going to say this, right? This is what given in your book, so I am following this particular method. Okay, so here what we are going to say, right, this is a standard formula of the relative refractive index. Okay, this was the first formula we did. Okay, second formula we did. This is the third formula, right? Okay, so how will we are going to go? This is medium 1 and medium 2. Let's say medium 1 is let's say medium 1 is water and medium 2 is glass, right? So if I'm writing this refractive index, okay, refractive index of medium 2 with respect to medium 1, listen to me, refractive index of medium 2 with respect to with respect to with respect WRT with respect to medium 1, refractive index of medium 2 with respect to medium 1. This is how I need to say. Why? Because I'm comparing relative refractive index of the two medium. Okay, we can also say that relative refractive index of second medium, refractive index of second medium with respect to the first medium. Okay, we most of the time we do the comparison, or we compare the relative refractive index of the second medium with respect to the first medium, right? So that is why we write in this manner. Okay, so reflective index, how you are going to read? Reflective index of medium 2 with respect to medium 1, right? Which is equals to the ratio of sine of angle of incidence, okay, to the sine of angle of refraction. Clear, student? So light is, now when I'm talking of medium 1 and medium 2, that means the light is passing from water to glass, right? This light is passing, this is light ray, okay, this is light ray. Light ray, okay, passing from medium 1 to medium 2, right? Now coming to the next part, this is here also we made a definition of refractive index. Now coming to the next part, right? Here what am I doing? I am now comparing the two refractive index, relative refractive index of two medium with respect to each other. Okay, now when it is written n2 and 1, n2 1 2 and 1, I don't have to say n21, never say n20, it is n2 and 1. It means the light is passing, okay, it means that I am here comparing the reflective index of second medium with that to the first medium. We have already mentioned, I have already told you here. Refractive index of second medium with respect to the first medium, right? Now let's write it down in a form of a ratio. Okay, so when I'm comparing, comparison also always done in a form of a ratio, right children? So how you are going to write in a form of a ratio? So it's very easy. You have written 2 first, so 2 will come at numerator. 2 first, so 2 will come at numerator. Second, number 1 you have written second, it is on a second place, so this will come at denominator. One more thing I want to tell you, what we have done here, refractive index, okay, of medium 2, okay, with respect to medium 1. So whichever medium is coming after the with respect to will always take the denominator place, will always be written in denominator, will always be written at denominator. Clear, student? This is how you have to do. Now let us do the second one. Here I am comparing two medium, again same set of medium, but now what I am doing, I am comparing refractive index of medium 1 with respect to medium 2, refractive index of medium 1 with respect to medium 2, right? So when I am writing refractive index of medium 1, I have written 1 first, so it will go at numerator, and 2 next, so it will go to denominator. And again what I did, refractive index of medium 1 with respect to medium 2. So after with respect, what did I say? Medium 2. So definitely medium 2 will go at the denominator. So these are the two points which you can keep it in your mind. to just form the formula. Once you make the formula, it will be easier for you to substitute the value and get the answer, right? Now coming to the next point, where I compare the refractive index, okay, with the speed of light. Refractive index of medium with the speed of light. Here also I am doing the comparison. So even this case is coming under the relative refractive index, right? So what it is, this is very simple. Now let's write this. Okay. Refractive index of 2, medium 2 with respect to medium 1, right? So 2 will come at numerator because I have written first, n will come at denominator because I have written next, right? And even when I am telling refractive index of medium 2 with respect to medium 1, so with respect to what I have uttered, the medium 1, so that will definitely go at denominator, right? Now when you are comparing this with velocity of light in the two different medium, it will be just opposite. So this medium, refractive index of medium 2 you have written at numerator, but in case of velocity you are going to write velocity of light in medium 1, right? Here velocity of light in medium 2. This is just opposite of refractive index of this. N2 upon N1 is equals to V1 upon V2. Velocity of light in medium 1 upon medium 2, right? This is just opposite of this. Very simple, right? Here also what you are writing, refractive index of medium 1 with respect to 2. So 1 will come at the numerator, 2 will come at denominator. Clear? So the velocity when you are going to compare, so what you are going to write, because you have written the refractive index of medium 1 here, you are going to write velocity of light in medium 2 and upon velocity of light in medium 1. This will be just opposite of what you have written, what the ratio you have written over here. This is the ratio of refractive index. So ratio of, and this is the ratio of velocity, okay, of light in two medium. So ratio of velocity of light in two medium is just reverse, or it is just reverse of ratio of refractive index in two medium, right? And how do we get this refractive, and how do we get this V upon V2? Let's solve this. Let's take this for example, right? So what is N? N is a refractive index. And how do you show N? N2, right? So this is a refractive index of medium 2. We know that N is nothing but velocity of light in air divided by velocity of light in medium. Okay, so velocity of light in air C and velocity of light in medium, so definitely it will be V2 because we are talking about medium 2, right? Now what about this N? What is about this N? N1, right? N1 will be velocity of light in air, and then velocity of light in the medium 1, because you have taken N1, right? So N velocity of light in medium 1, right? Then just reciprocate C upon V2, and this will become into this, V will come up, isn't it? This fraction, okay, when will come up, it will get reciprocate V1 upon C. So this C will get cancelled, and this is how you are getting V1 upon V2, velocity of light in medium 1 and velocity of light in medium 2, velocity of light in medium 1 upon the velocity of light in medium 2. This is how we have derived this formula. Clear? So we have done 4 formulas of refractive index, right? This is formula 1. This is the first formula, right? And this is the second formula, right? And this is the third formula. These two together, this third formula, right? This is fourth formula, and yes, this is the fifth one. So altogether we did 5 formulas, right? But 1, 2, 3, 4. These 4 formulas are the formulas to find out refractive index. So we have 4 formulas to find out refractive index. Clear? And this, in this way also you can find out refractive index. So altogether 5 formulas to find out refractive index. Now let's go for the numerical. Right. What is the refractive index of the medium in which the speed of light is 1.5 into 10 to the power 8 meter per second? Right. What is the refractive index of medium in which the speed of light? So we have to find out the refractive index of medium. Now what is given? Okay, given here, this is not given, so I'll just erase it. Okay. Okay. In case of given, they have given the speed of light in medium, right? So speed of light in medium, that will be v. Speed of light in 1.5 into 10 to the power 8, and we know the speed of light is 3 into 10 to the power 8. What is the unit of speed, or what is the unit of velocity? Meter per second. There also meter per second. Don't forget to write unit. And what you have to find out? You have to find out refractive index. So n you have to find out. Put a question mark, and what you can, which formula you have to use here. You can conclude that which formula you can use here. It is your formula of absolute refractive index, n is equals to c upon v. Okay, so whatever is given to you, on that basis you can know the formula. And what I am supposed to find out? I have to find out the refractive index right here. So 3 into 10 to the power 8 divided by velocity of light in other medium is 1.5 into 10 to the power 8. Okay, so this will get cancelled, and this will become, I have to remove the point. So to remove the point, it is very simple. Just put 1 0. After the point, how many numbers are there? One number, right? So after 3, I am going to put 1 0. That's it. Okay, so and 15. So 30 divided by 15 is 2. So refractive index, okay, of the medium is 2. There is no unit. Why there is no unit? Because this is the ratio of the same thing, right? Now the next question, the refractive index of glass with respect to air. Now see, refractive index of glass, okay, with respect to air. Am I supposed to write air here? No, no need. Refractive index of glass with respect to air is nothing but the refractive index of glass, right? So you can just write Ng. You don't have to write air here, because this is absolute refractive index, right? So absolute refractive index shows that it is a refractive index of medium, because you are comparing with the absolute refractive refractive index of a absolute quantity. Okay, so air is the absolute quantity. Why? Because speed of light in air is highest. Okay, so Ng, you have to write just Ng. You don't have to write with respect to air. For that you need no need to write anything else. You can write just Ng, right? And what is a refractive index of glass? It with respect to air is 3 upon 2. Okay, and refractive index of water with respect to air. So I can just write, Nw is 4 upon 3. Now then, what will be the refractive index of glass with respect to water? Now here you need to know, okay, what should be the refractive index of glass? Very simple. In NCERT they have given very simple way. Glass with respect to water. So glass with respect to water, done. Glass with respect to water, done. So because I have written G first, so I am going to write refractive index of glass first, and because I have written W next, so that will go in denominator. Okay, and one more thing, refractive index of glass with respect to water. So after with respect, which medium came? Water came, so water will go down. Okay, so there are 2 points which I have told you. Okay, so here what is the refractive index of glass? 3 upon 2 divided by 4 upon 3. Clear? So what will happen? This will reciprocate 3 upon 2. This fraction will go up, but it will get reciprocate. It will become 3 upon 4. So you will get 9 upon 8. I want you to divide 9 divided by 8. Okay, the answer is written here. So further you have to do it by yourself. Right. Right. With respect of air, the refractive index of kerosene is 1.44. Right. Now let's write refractive index. Right. So with respect to air, again, I don't have to write K and A. I can just write kerosene, refractive index of kerosene, right? Because that is the absolute refractive index. Okay. So whenever you compare the refractive index of medium with air, that means it is absolute refractive index. So you can just write refractive index of kerosene, okay, which is 1.44, and that of diamond, again refractive index of diamond, and I have written D, okay, is 2.42. Okay. Calculate the refractive index of diamond with respect to kerosene. Now how should be the ratio? What should be the ratio? Because with respect to, after with respect to which came, kerosene came. So where will kerosene go? Kerosene will go down. NK, I have written first down, okay, denominator, and this is what? Refractive index of diamond, right? Can I write here now? K refractive index of D, because I have written first D, so I can write D here first, and then K came next, so I can write K. So how you are going to read? Refractive index of diamond with respect to kerosene. Simple, right? I am done with formula. Now just substitute the value. Where is D? D is 2.42, right, divided by 1.44. So if you do the division, okay, you do the division by yourself. So because after decimal there are two values here, after decimal here also two values, so decimal will go off, and what you will get? 242 divided by 144, right? This decimal has gone off, right? Let me correct it. Okay, I'll just erase it, otherwise you will get confused. I'll write 2.42 and 1.44. Okay, this will get cancelled. 240 divided by 144, so it will be coming 1.68. The answer is given. You need to do the further calculation by yourself, because this is simple division. Okay, let's come to the next one. A beam of light passes from air into a substance X. That means the first medium is air. What is medium 1? Medium 1 is air. Air is medium 1, and medium 2 is nothing but some medium X, variable, right? If the angle of incidence is 72 degree, okay, and the angle of refraction is 40 degree, okay, then calculate the refractive index of substance X. Now we have to use another formula for this. What was another formula for refractive index? N. Refractive index of substance X, N, is equals to sine I upon sine R. Clear, student? Now sine I 72 degree, angle of incidence 72, right? It is degree divided by 40 degree, 40 degree, right? Now what is the value of sine 72? It's sine 72, sine 40, right? Sine 70, the value of sine 72 is 0.951 divided by 0.642, right? After that you will get the answer 0.75. Clear? Do the division by yourself, children. Okay, let's go to the next question. Here comes MCQ. Okay, now refractive index of transparent medium is greater than 1. Refractive index of transparent medium is greater than 1 because let's see the options. If speed of light in vacuum is less than speed of light in transparent medium, absolutely wrong. Speed of light is highest in vacuum, so it can never be correct. Speed of light in vacuum greater than the speed of light in transparent medium, right? Speed of light in vacuum should be is equals to no frequency of light wave changes when it moves. No, okay children, frequency never changes. There can be the change in the speed of light, there can be the change in the wavelength of light when it passing from the one medium to another medium, right? But there can never be the change in the frequency. Frequency depends upon the source of the light, right? So this is the perfect answer, B1. Coming to the next, as light travels from a rarer medium to denser medium, right? From the rarer medium, okay, light travels from the rarer medium to the denser medium. Let me draw normal first, right? Okay, you draw this line, okay, which is a boundary line between the medium 1. Let's take this is air and this is water. Okay, so this is the boundary line between the two medium, and after that you need to draw normal. Okay, travel rarer to the denser medium, it will have increased velocity. Will the velocity increase? No, velocity will not increase because light is, what is happening to the refracted ray? It is bending towards the normal, so it bend towards the normal only when the medium is denser, right? Okay, velocity will not increase, velocity will decrease. Yes, velocity is decrease in wavelength. Yes, I have just told you that it depends, the velocity and wavelength, they are dependent on the optical density of the two mediums. So both B and C is the correct answer. The angle of incidence I and the refraction R are equal in a transparent slab when the value of I is, so when the value of I, when can be the value of I is 0? Yeah, when the angle between the incidence and the normal is 0. Okay, so when the value of I, when I angle of incidence is equals to 0, right, then only this line, this incident ray is perpendicular to the perpendicular to the boundary of the two medium, right? So 0 is the correct answer. Refractive index of light is refractive index of water is 1.33. Here I want to tell you one thing, children. You try to learn refractive index of few substances. Refractive index of water is 1.33. The speed of light in water will be, now we can use the formula N is equals to C upon V, because we know refractive index which is given. Okay, so 1.33, okay, is equals to refractive, the speed of light in water. We know the speed of light in air is 3. This won't be given. Speed of light in air will never be given. You have to know that speed of light is 3 into 10 to the power 8. Okay, then what should be the velocity? Okay, you have to find out. So just change this position. So velocity is nothing but 3 into 10 to the power 8 divided by 1.33. Okay, you will get the answer. And what should be the answer, that you decide by yourself. Do the calculation and get the answer by yourself, children. Okay, this much I have done. The further calculation you are going to do by yourself. Yeah, you are given three media A, B and C of refractive index 1.33, 1.65 and 1.46. The medium in which the light will travel fastest is, of course, the medium which has less refractive index. Medium which has less refractive index, that means its optical density is less, and it means the light travel faster in that medium. So it is water. Okay, so what have we given? Okay, A, B and C. So the refractive index 1.33, this means the medium in which the light will travel fastest is this, A. The answer should be A. Okay, children. Now coming to this, a student traces the path of a ray of light passing through a rectangular slab for three different values of angle of incidence. So he has made angle of incidence, and he has taken three different values of angle of incidence, that is 30, 45 and 60, right? So angle of incidence he has changed. Okay, he extended the direction of incidence, and once you take the angle of incidence, you should extend this angle of incidence to find out what? To find out lateral distance, right? So you need to extend. So he also extended by dotted line and measures the perpendicular distance. He measured this distance between the extended incident ray and the emergent ray. So this is what is emergent ray. Okay, this is your emergent ray, small e. Fine. He will observe that, I have discussed this before, he will observe that the L keeps on increasing with increase in the angle of incidence, keeps on decreasing with decrease in the angle of incidence, keeps on decreasing with increase in the angle of incidence, or L remains the same for all three angles of differences. No, no, no. L is maximum for angle of incidence 45y and is less than its value for angle of incidence 30, and no, this is not correct. We have already done the concept of lateral displacement, that if you increase the angle of incidence, the L is also increase. Okay, so this is the right answer. Now suppose I have given you an experiment and you have to, I have given you a slab and I have given you a protector and I've told you to draw a line of incidence, in which manner you are going to keep your protector, because that is also important, na? Right? So a student traced the path of a ray of light passing through a rectangular slab. So he has placed the protector like this. So why he has placed the protector like this? Okay, where is this normal? How did he get normal? So this is wrong. This is also absolutely wrong, because this is the normal. Okay, normal is 90 degrees. This is the normal in this case. This is also wrong. So this is the perfect, because this is a normal of this surface. This normal should coincide with the 90 degree of the protector. So this is the perfect way to keep protector. For measuring the angle of incidence, he must position the protector in the manner shown in the figure. So figure D is the perfect way of keeping the protector, and here we have ended the session. Children, I want you to please revise the whole thing again. Thank you so much.